I did. And sir, can you just recap the three derivations again?
Good. Yes, absolutely. Yeah, so why not? So we have to, and what about this one? The last derivation, the speed at the nth time. What about this one?
So which one?
The fourth one, this one, fourth one.
So the fourth one is not very important, right?
Yeah, this is
Only
also
the
important.
first three. Okay.
Derivation. Yeah, derivation is not that important. Derivation, yes, derivation is not important, but we have to just remember this thing, right?
Yes, sir.
Yes. Okay, so now let us revise this thing. And before we recap, so the first thing that we have to remember that the calculus portion. So calculus
So
portion,
my sir in school, he did it
yes,
like in
yeah,
a more smaller way, not like with long steps, like for all the three.
smaller steps, yeah. So the small way, so they
V
didn't
is
use,
equal to yeah, like
yeah.
I don't know, he made it small.
Because we are writing all these steps, right?
Yeah,
So that is why these steps are long. Because
okay.
yeah, if we skip some steps, then it would be unclear, right? So yeah, so okay, so yeah, so he used the calculus to derive those relations.
Sir, he did not teach us calculus. He just derived it and he just told to learn it.
And
That's it.
so without knowing the calculus, how we can understand what is happening, right? Without
I mean,
understanding
I
the
was able to answer in the class because like you already taught, like he was
hmm,
asking how will you
hmm,
derive the third or the second one. So I was telling that with the second one you
hmm,
can derive the third one like that, and you
yeah,
can replace A with B minus U like that.
hmm, hmm.
Um, Other than that, he didn't, I don't know, teach like that.
Okay, so yeah, it maybe his way of teaching is different, right? Because everybody has different personalities, so every teacher is different, right?
Yeah.
So maybe his way of this would be his way of teaching, right? And so he didn't teach the calculus portion at all. No integration,
No,
no differentiation,
no.
and then he used these things in the class.
Yeah. He, one person, they asked him to teach that, but he told he'll teach after the chapter ends.
Mhm.
That's,
So how this helps? Because you are using that thing, so you should know this thing beforehand, right?
yeah.
Okay, yes. Maybe he will teach after that and when. But you, yeah. So have you recapped all those differentiation, integration, and then vectors part? Have you
Yes.
revised those? Yeah. So just recap time by time, time to time. Just recap all those things, right? Because
Yes.
that would be very helpful. So yeah. So what are the things that we would be using to derive all those relations? We would be using calculus, and in calculus we would be using differentiation.
Yeah.
Right. So we have all those relations. This I will talk about later, and integration also. So in integration, we would be using, right, algebraic one. So only the algebraic one we would be using. Algebraic integration. What is this algebraic integration? Let's say if we have xn and then the dependable variable is x. So with respect to x, we are integrating this function. And what is the function? Function is x to the power n. So how do we write the integration? This is something like fx and then dx, right? So whatever this function, this should be the function of x because with respect to x, we are integrating. So if I'm
Yes.
writing, let's say f t square, and then I'm integrating with respect to dx. So
T4
then
plus
I,
T4 by 2 dx.
yeah, so this
T
would
raised to the
not,
power of 2.
yeah, so this is t. So this is not function of x. So this we cannot integrate, right?
Yeah.
So xn, we have to remember this relation that this is xn plus 1 and then n plus 1. So this is the thing. So now you tell me, if I have dt, then function should be what? This should be t only, right?
Yeah.
So let's say this is t square. So what would be this integration?
That would be integration of T4 by 2 dt. T raised
T4,
to the power of 4 by 2 dt.
why this dt is coming? So this is t square.
And plus 1, 3. Sorry. T raised to the power of uh, 3 by 3
Yes, that
dt.
is all. So why you were getting T4 by dt?
No, I was doing what 3 plus.
You were doing a differentiation.
I just added more. Yeah. No.
So yeah, so just revise all these portions. These are very crucial, right?
Yes, sir.
So revise it again and again, and then you would be very yeah, frequent with these things, right? So okay. So let's now we remember this thing, right? So let me ask that what would be this thing t dt? What would be this integration?
T raised to the power of 2 by 2.
Good. So now you have become fast, right, in integrating. So yeah,
Yeah.
so just we have to recap all these things again, and then yeah, it will be easy to remember. And there is also one important integration, and that is that whenever you are integrating this thing only, you don't have
Yeah.
any function. So then you will get this variable, right? So if I integrate dt only, then what would be this thing?
X.
This
No.
is t.
T.
T only, right? So yeah. So this is the part that you will be using. And yeah, in differentiation, what we will be using. So we have to remember the relation. And what is the relation? That we have understood already, that we have instantaneous acceleration, we have instantaneous velocity. So velocity is what? What is velocity? What is instantaneous velocity? What happened? So this is dx by dt, right?
Yeah. Yeah.
And then we have acceleration, which is dv by dt. So these two relations we have to remember, and some calculus proofs.
Yes,
And
sir.
then we can derive all these things. And the third important point is the what? What was the third important point?
To remember the first 3 formulas.
Hmm. Yeah, so those things we want to derive, right? So those were the initial and final conditions, right? Initial and final conditions. Why this is important? Because this will give us the lower and upper limit of the integration, right? Because we are doing the definite integration, right? We are doing the definite integration, so that is why we require this lower and upper limit. So in our integration, we will have x1 and then x2, right? So if I
Yes.
integrate this thing, then I have to place this upper limit and then lower limit. So what would be this thing? So this would be x2 minus x, right?
Yes, sir.
because in place of x, first I have to put x2. So this would be x2, and then in place of x, I have to place the lower limit. So that is x1. So this is the thing, right? If the function would have been square, so then what would be that thing? So this is, let's say, t1 and then t2. So this would be t2 square minus t1 square divided by 2. Right?
Yes, sir.
Okay, so these are the things that we have to remember. And I will write this one as this index. And then I will write the value. So, yeah, so we have initial condition. Initial condition, and what was that? So initial condition was the first position, x1. That was 0. The initial time, that was 0. Initial velocity, right? Let's say v1. This was u. So this was initial condition, right?
Yes, sir.
And then we have final condition. Final, yes, condition. What was that? This was final position. This was S. And then we have final time, that is T. And then we have final velocity. This is V. So these are the things that we have, right? We will use all these things. Clear?
Yes.
Okay, so now we have the setup. We have the basic setup to understand all those three derivations. So first, we want to derive the first equation. Oh, what happened to this? So first equation is V equals to U plus 18. So in this, what is happening to this thing? Why this is, what is happening to this thing? Yeah. Okay. So this is V equals to U plus 18. So do we have any distance in this relation? Any distance?
No.
So then let's say we have two relations, right? We have V, which is dx by dt, and then we have A, which is dv by dt. So in which relation we don't have distance? And in which relation we have only velocity, acceleration, and time? Which relation?
We have in the second one, so we can
Second
use it.
one. So we can use the second one, right?
Yeah.
And one important thing that we are using or we are doing the uniform acceleration. So all these equations are for uniform acceleration, right?
Yes.
So all these are for uniform acceleration. So then what we do is that this A is constant, right? So this A is constant. So now let us use this second relation. So we have V, which is, we have A, which is dV by dt. We take this thing the other side. This is dV, and then this is A dt. We integrated both the sides. I will not write all the other things. So what would be the limit in here? This would be V1, V2.
Yes.
And in here we have limit T1, T2. Right.
Yes, sir.
Now, what is this integration? We don't have any function. So what is this integration?
V and V minus U or something.
No, no, no. So this integration, what is this integration? Yeah. So let me ask you, what is this integration?
dV, V.
This one, this is x, so this would be
That's
v.
X. That would be V.
So this is the only thing, right? where
Yes, sir.
if we don't have any function, so this is the variable is the integer. So this is v. So this is v, and then the limit is v2 and v1. Right. A is
Yes, sir.
constant. A is constant, so it can come out of the integration. And then the integration is dt. So what would be this integration? Can you tell me?
Sir, the A is outright, so it will be uh, A
What is
into
this
T
integration?
only. T only, yeah.
T1,
So
T1. So this
A
is
bracket T, and then T, and then T1.
yeah.
Okay.
So now this is the integration. So we have done the integration. Now we have to put the upper limits and the lower limits. So let's put that. So what would be this thing?
So
What would be this thing?
V2 minus V1
V2 minus V1. Absolutely
is
correct. And then this is A.
into T2
2 minus.
minus T1.
So this is all. Now we will put the conditions. So we know that V2 is V, V1 is V. Right. And then this is A, T2 is T minus 0. So this is V minus U, this is AT. So we can write it as U plus A. So yeah, this must step we will need. So any
So
doubt in this?
he finished it in 3 steps. Yeah.
Yeah. So he finished it in 3 steps.
Yeah.
So yeah, from here I can write directly that this is V and then V2 minus V1, or I will directly write that this is
He didn't use that. He didn't use it at all. He
yeah.
just
So
wrote the direct
the
like
integ
formula.
the direct one, yeah. So then we can directly write that this is T and 0. Then we can write V minus U AT. So yeah, we also can write this thing right in 3 steps. But these are the important steps. How we are getting these things right.
Yes, sir.
Yeah. So we are doing this in more elaborate way, right? So that we
Yes.
can understand what is happening. And you can write all these steps, right? So
Yeah.
okay, so is it clear now? Is this one
Yes, sir.
clear?
Yes, sir.
Yeah. And good that you practiced and then you found some, yeah, so doubts. So good.
Yes.
And yeah,
And sir,
this,
you had
yeah,
sent the question paper last time, remember?
yeah. So did you find the answers for those ones?
I didn't know what I had to do in that. Like,
Okay,
can can you
good.
tell what I had to do in that? Because you
Yeah,
gave the question paper and then I didn't know what to do.
yeah. But what about the first question? Uh, did you?
First question, I think I understood, but I did not solve it because I didn't know what to do.
Yeah, so first question was about the dimensional formula. Okay, so
No.
let's good. So yeah, so today's question is just for the doubts section, right? So good. This one we have 35 minutes more. So should I or do I need to do all the second and third derivations as well?
Sorry, sir?
Yeah, so should I do the second and third derivation as well?
I think so.
Okay, so what should we do first? The that question paper. Oh, let's
First
yeah
derivation, first derivation.
yeah. So let's understand this derivation first, and then we can talk about those questions. So yeah, the second equation is second equation is S equals to ut plus half at square. And again, we have two things. V is equals to dx by dt, and then we have what? And then we have A equals to dv by dt. So this contains the distance, right? So we will use this thing, and we know that what is this final velocity. So dx by dt, this is v, And we know that what is this V? V is U plus 80. Right.
Yes, sir.
So then we take this thing the other side. So this becomes dx, and then this is U plus 80, and then dt. So we can write it separately. This is U dt plus this is AT dt. Right.
Yes, sir.
Now we will integrate it both the sides. So what would be the limit for this one? X1, x2.
Yeah.
T1, T2, T2, T1. Right.
Yes, sir.
So what is this integration? Dx. What is this integration?
X2
X.
minus X1.
So first X only, and then
X is equal to T2 minus T1 plus.
yeah, and then this is U is a constant. So
So
you
U will
will
be outside.
come outside, and then dt integration, and then this is T1 and T2. Again, acceleration is constant. So this comes outside, and then you have a function. In this case, you don't have any function. In this one, you have a function. And
Okay.
this is T1 and T2. So now, as you said, this is x2 minus x1. This is U, and this is integration is T. And then T2, T1. And then this is A. What is this integration? Who's texting?
T2 minus T1.
Okay. So this, oh,
No,
what is
T
this integration?
square by 2.
And then this is T2,
T2
T1.
minus T1.
Not T2 minus T1, the upper and lower limit, T2 and T1.
Yeah.
So this is x2 minus x1. Then this is U and T2 minus T1. And then y2 is outside because this is a constant. What would be in here? First, we put the upper limit. So what would be that? In place of T, we have to put T2. So what would be the
Okay.
function?
T2 minus.
Function is T square, right?
Yeah.
So if I put, let's say x square is function, in place of x, I put 3. So what would be the function?
6. 3 to the 6.
X is 3. So this would be 3
Oh,
square.
it's 3 square like that.
So then this function is t square. If I put t2, so then what would be the function?
T4.
T2 square, right? Is it
Okay. Yes, sir.
yeah?
Yes, sir.
In place of t, I have to put t, right? So this is
Yes, sir.
t2 square. And minus what would be in here? Yeah, now we have to put the lower limit. So what would
T1.
be T1, and then the function is square, right?
Yeah.
So this would be square. Now we put the value. So x1 is 0. So this is s minus 0, u t minus 0, and then a by 2 and t squared minus 0 squared. Right. So then this is s, this is ut, and then half at squared. So this is how we derive the second one. Any doubt in this one?
No, sir.
Yeah, so and you have already noted down this part, right?
Yes, sir.
Okay, so please look at the derivation and please tell me that any steps that is unclear to me. Please check that.
Sir, can you do the T square by T by 2 bracket T2 and T1?
This one.
Yeah.
Okay, so good. So let's say that what is the function? We want to integrate. Let's say this is time is 1 second. Let's say time is 1 second to let's say 3 seconds. These are the time. So then limit would be 1 to 3. Integration is t and then dt. Is it clear?
Yes, sir.
So now if I integrate this thing, so this would be t square by 2 and then the upper limit and lower.
Okay.
Clear?
Yeah.
Now this is a number. Function is what? Function is only t square. This is the function. And 2 is a number, so it comes outside. Then you put this upper and lower. So in place of the function, you first put the upper limit. So what would be that? What would be that?
Sir, you put 3, T3,
Yeah,
and
t3.
then
So
you
the
put
function would
square.
be, yeah, first I put t equals to 3, then what would be the function? That is correct. So in place of t, I have to put 3. Then what would be this function?
3 squared.
3 square, right? And then
Yeah.
minus of
1 squared.
1 square. So that is the same thing we are doing. In place
Okay.
of 3 and 1, we have t1 and t2, different times. We are not, we don't know the exact values because that thing we'll put in the end because we know that t1 is 0 second, t2 is t second. That thing we know. But
Yeah.
as of now, we are not putting the values. We have just different t1 and t2, right? Initial time, final time. So
Okay.
we have the function t square and then final time and initial time. So in place of t, we first put t2, that is some final time. We don't know t2, so that is just a notation. This t2 square and then in the lower limit, which is t1, so t1 square. So 3 square minus 1 square. And then we put what is t2. T2 we know that is t, t1 we know that is 0. So that is how we do this problem. Is it clear?
Yes.
So let's say if I have x cube dx and then limit is to 4. So can you tell me what would be this integration?
It would be 4
First
cube.
integrate this thing. First integrate this thing. First we have to integrate this thing.
Uh, X raised to the power of 4 by 4.
4. And then we put
In the bracket 4 and 2. 4 and 2. Yeah.
now
Then
this
you
4.
put,
Yeah. So now tell me what would be the answer.
sir, 4 raised to the power of 4 minus
Good.
1 raised to the power of 2.
Where this one comes from? What is the lower limit?
4.
What is the
2.
lower? Yeah.
2 raised to the power of 4. Okay.
Yes. Good. So this is yeah. This is the answer.
Okay.
So yeah, this is the idea of the definite integration, right? First we have to put. This is the function. Function is x to the power 4, and in this function, right? We have to first find out what is the upper one. In place of x, we have to just put 4.
Okay.
And then what is the lower? In place of x, we have to put 2. So that is 2. Right.
Yes. Yes.
So yeah, this is the idea of this part. So is it clear?
Yes, sir.
Okay, so now the last one. What was the last one, right? So the last one is this one. Right. And now, as we discussed earlier, that we cannot use the usual relation. So we have A, which is dv by dt, and we have v, which is dx by dt. So this doesn't contain acceleration, so this we cannot use. But yeah, this thing, the idea we will use, right? So let's not
Yes.
totally discard this thing. So this we will use, but yeah, this is the thing that we will use. But
Yes.
in this thing, in this relation, we don't have we do in this relation we don't have time, right? In this
Yeah.
one we don't have time, which means that if
You have to
from
derive
this,
it.
yeah, from this one we have to remove this time.
Yeah.
So what we did,
D.
we,
We
yeah, we
divided by
divided by,
dt.
yeah, we
Dx
multiply
by,
this thing and then
and
divide.
then you get it. Yeah.
And then we use this thing, dx by dt. So dx
dt.
by dt is v. So we wrote dv by dx. Now in this new relation, we have acceleration, we have distance, and we have velocity. No time. Because this has no time pass.
So it's dx by dt, right?
Yeah, dx by dt is v, right?
No, dx upon dx you would.
No, no, no. So we, because whenever we are doing something with any relation, we have to do it equally, right? So if we are multiplying by we are multiplying this thing by dx, then we have to divide it by dx, right? We
Okay.
cannot, yeah, because let's say if we have 4, which is, let's say, which is 8 by 2, right? So
Yeah.
to keep this thing same, if I multiply it by 3, if I divide it by 3, then this will remain the same, right?
Yeah.
So I cannot multiply this thing by 3 and divide it by 4. So this will change, right? This will completely change. So this will become what? So this will become 24, or this is 2. So this will become, and this 2, and this will become 3 only, right?
Okay. Yes, sir.
But in this one, 3 and 3 will cancel, and 2 and 2. So this will become 4 equal to 4 only. So this
Okay.
relation will not change. If I
Okay.
multiply the same thing and divide the same, right?
Yes, sir.
But if I multiply with this thing and divide it by different thing, then the answer will completely change, right? So if
Yes.
I multiply by dx, then I have to divide it by dx, right?
Yes.
Okay, and why did I divide it or multiply it by dx? Because dx by dt will be this right? So
Yes.
it will reduce this time part. It will remove this time. So that is why we multiply this thing and divide by this thing. So this was the idea. Clear?
Okay. Yes, sir.
And now what is the thing that we have? We have a, which is v dv by dx. So this is the function of v, right? So we'll take
Yes,
this
sir.
thing in the left hand side. So this would be a dx, and this is v dv, right? And
Yes.
yeah, let's write this thing in the left hand side. So this is v dv, and this is a dx. We integrated both the sides. So in here the limit is v1, v2. In here the limit is x1, x2. Right.
Yes, sir.
Now let me see if you remember this thing or not. So we have the dependable quantity with respect to we are integrating. So this is v. Function is v. So what would be this integration? Let me see if you remember this thing or not. What is this integration?
Your VDVs, right?
Yeah, so the parameter with respect to your integrating is v.
V.
So and the function is v. So what would be the integration? You have just done the same integration in the previous calculation. Same integration. Only the notations have changed. So
V only. V
So
and
you are
then.
saying that integration of v dv would be v only. Then what would be the integration of dv?
Sorry, that is V.
That is, So we have a function v. Then what would be this integration?
Oh, like that. A v square by 2.
Yeah, so this is correct. So why you got
No,
confused?
I thought you were telling about the other thing which you taught.
Yeah, so which one?
No, the uh, t square by 2
Yeah, so that
into.
is the same. Yeah, that is the same integration that we have done. T dt.
Yeah.
Yeah, so this was I was telling, right? That we have done the same integration, but
Yes.
only the notation have changed. So this has become v and this has become v. Yes, you are correct. So this would be v square by 2. And now because we have extensively talked about this thing, so this you can tell. A is constant, right? So this comes out and then we have integration dx, x1 and x2. So before we do this integration, you tell me this 1 by 2 comes outside. This is v square and then v2, v1. And what would be this integration? What is this integration?
So just x.
X and then we have the upper limit.
X2
Good.
and x.
Now tell me that what would be this, what will come first? So what would be the first term? Remember, we have to put only the upper limit first.
v2 the square minus
Yeah,
v2
good, good. V2 square minus,
v1
now the up,
square.
V1. Good, good, yes, correct. So as because we have understood the t square t square one, so yeah, this becomes similar. So this is a x2 minus x1.
Yes.
Good. Now we know that what is the final velocity. Final velocity is v. Initial velocity is u. And final distance is s. Initial is 0. So this is v square minus u square by 2. And then as, this t2 goes the other side. So we have the final relation. Clear? Any doubt in this one?
No, sir.
Okay, so yeah, have you noted down this part?
Yes, sir.
Okay, so now any conclusion in this these derivation? Please, you have to revise these things again, right?
Yes, sir.
So yeah, please practice all these derivations, and the only thing that you have to keep in mind is these three things, right? Calculus, these two relations, and then initial and final condition. So if you
Yes.
remember these three things, then you can derive all these relations, right?
Sir,
Yes.
can I go for prayer?
Oh, so you want to go for prayer. So this is Maghrib's prayer, right?
Yeah, I'll just come back in 5 minutes.
5 minutes. Yes, yes, please. Pray for me also, right? Pray for me also.
Yes, sir. Yes, sir. Sure.
Yeah, so yeah, be back in 5 minutes.
Yes. I'll just make wuzu and just pray, okay?
Yeah,
No,
yeah, yeah.
wait. Azan is happening now. Sorry, sorry. You can continue. Okay.
Azan is happening now. Yeah, so yeah, okay then. We have 15 minutes more, right?
Yeah.
So yeah, after this 15 minutes,
It's
so
1 hour. It's 1 hour class.
1 hour, right? Yeah, 1 hour. So this is an extra class, so we can keep it
Oh,
for
then
1 hour.
fine. It's okay. Then we can finish the class and then I can leave. It's okay.
Yeah, yeah, yeah. So let me check what is. Oh, so this is 7:30 to 9 p.m. Let me ask the Learnivio team. Right. Yeah, let me just call them because this is an extra class, right? So give me one moment. And if this class is supposed to be 1.5 hours, then you can go for prayers. Otherwise, yeah, so you can do after this, right? So let me just confirm. Okay, yeah. So this is for 1.5 hours, right? So yeah, you just go for your prayer and then be back in 5 minutes, right?
Yes, sir.
And then we can discuss these things.
Yes, sir. sir.
Yes, yes, I have returned. Yes, so you have returned.
Yes.
Okay, good. So now any confusion in these three derivations, these are very important. So any confusion in this one,
No, sir.
then we can talk about the questions that I have sent you, right? So those are very, very, very important questions. So let me, what should I name this thing? So this one is the, what should I call it? Practice. Paper. And let me bring that yes. Right, so this was the first question,
Yes,
right?
sir.
So first question is just the dimensional formula of the following. So this one we have not done. Specific heat, surface tension we have not done. Young's modulus, Planck's constant, all the rest we have done, right? So let's say we have power, right? So what would be the dimension of power? So power is what? Force by area, right?
Yeah.
And what is the dimension of
Is it time, right? So it will be ml squared t minus 3 t raised to the power minus 3.
yeah, so this is force which is mlt minus 2, and then area is what is the dimension of area? Dimension of area. Yeah, so I have told you that we can identify, we can memorize the dimension by just remembering the units. What is the
Yeah,
unit
yeah.
of area?
Is it like m
Area.
L1?
What is the unit of area? How do you represent the area? Unit of area. Area is meter square, right?
Yeah.
So this meter is length. So this would be L square,
Oh,
right?
yeah.
Right.
Yes, sir.
So now we have L power 1, and this is in denominator. So it will go, if it goes in the numerator, this becomes minus 2. So this would be M L1 minus 2 and then T minus 2. So this would be M L minus 1 T minus 2. So this is the dimension of pressure. Uh, oh, wow. We have power. Oh, I thought this is pressure. So this is pressure, right? Sorry, sorry.
Yes.
This is pressure. Okay, power. Yeah. So power is energy by time or work by time, right?
Yes, sir.
And what is the dimension of work? So the work has the same dimension as energy, right? And
Yeah.
what is the dimension of energy? This is ml square t minus 2. This is the dimension of energy, right?
So it will be,
Yeah, so this would be, or if we don't know that this has the dimension of energy, so we can write that work is force into distance.
okay.
And then this is time. So again, we know that what is the dimension of force, or if we don't remember the dimension of force as well, right? So if we don't remember the dimension of force, so we know that force is mass into acceleration.
Okay.
So we can write this thing in here. So force is mass into acceleration, and then distance, and then time. So what is this thing? What is the dimension of mass? Dimension of mass.
Sir, it is m.
M only. That's yes. So
Yeah.
why? This is M only. What is the dimension of acceleration? So just remember the units. Unit of acceleration is meter per second square. Right. So meter is length. So this is L. Second is time. So this is T. Square is minus. So this is LT minus 2. Distance. What is the dimension of distance? Yeah. What is the dimension of distance?
This
Yes.
L.
L,
L.
right? So why you are confused? Why you are confused? This is, yeah. So this is time is T. So this is L square, right? L into L is L square. And this is T minus 2. Oh, so did we miss something? Yeah, so this is power, right? So this is L and this is minus 2, this is minus 1, so this is minus 2. So this would be the dimension of power. Right. And what I was telling is that if we know that work has same dimension as energy, so this is ml square t minus 2. And power is work by time. So this is ml square t minus 2 and then by time. So this would be again what? Let's get the same answer.
Yeah.
So yeah, if you remember that work, energy, and yeah, different kinds of energy, whether it is heat energy, whether it is kinetic energy, whether it is potential energy, all those kinds of energy, they will have the same dimension. So if I ask you that what is the dimension of kinetic energy, you can directly tell me what would be the dimension.
Sir, can you repeat again?
So what would be the dimension of kinetic energy?
ml and then T2
ml square t minus 2.
T minus 2.
Because this has the same dimension as energy, right? So this is energy.
Yeah.
And this will
Okay.
have the same dimension as potential energy.
Okay.
Right. We can derive this thing also, that kinetic energy. So have you noted down all these parts? Have you noted down?
Yes, sir.
Okay, so we can derive this thing as well, right? And how we can derive this thing? So what is the formula for kinetic energy? This is half mv square, right?
Yeah.
And in dimension, we don't write this number. These numbers we don't write. So the
Yes.
dimension of kinetic energy, this would be m, which is m. And this is v. So what is the dimension of v? Velocity. What is the dimension of velocity, which is speed?
Dimension of velocity is
So I guess I have to recap this
sir.
dimension.
Sir, it is m L1 T minus 1. T
Good.
minus T
So
minus 1. Yeah.
yes. Yeah. So if you remember the dimension, so the unit of velocity is meter per second, right? So
Yeah.
this is L T minus. So yeah. By taking the analogy of the units, we can just remember these things, right? So good. And then square. So this is m L square and T minus 2. So you see that this has the same dimension as energy,
Yes.
right? So all kinds of energy. those will have the same dimension as ml squared t minus 2.
Okay.
Momentum. What would be the dimension of momentum?
Dimension of momentum will be.
This is mass into velocity, right?
Yeah.
So mass is m,
And
velocity
then
is lt minus 2.
this one.
So this would
M
be
by
m.
LT.
So this is momentum, right? Oh, so
Yes.
velocity is there. What is
Yeah.
velocity? Velocity is displacement or distance by time.
Yeah.
So distance is L divided by time. So LT minus, right?
Yes.
And we have force, so we have derived force. We have derived momentum, we have derived kinetic energy. What about acceleration? Okay, so let's do that. So yeah. And if you have any doubts in this part, so then we can also discuss all these things again, right?
Okay.
So I can recap
So
this.
no, I already know this. I just didn't revise it like because I
Hmm.
was doing other things. But then I
Yes.
know this.
Yeah, yes, yes. So, yeah, good. Okay, so then let me just write the formulas for all these things, and then you can. Okay, but before I do that, you just do this as your homework, right? So just
So
do this.
specific heat, like how do you?
Okay, yeah. So then let's talk about specific heat, tension, modulus, and Planck's constant. So to derive all these things, we need to remember the formula. So what is specific heat? So this is related with the change in temperature. So let's say you are boiling water, right?
Yeah.
So when you heat up water, then the temperature of water will increase, right?
Okay.
So how much the temperature will increase? So that is determined by this specific heat, right? So let's say you are providing the heat energy, right? So this heat energy, this is represented as Q. This is equal to the mass and then the change in temperature. So this is heat that you are providing to the water. This is the mass of the water. And then this is the change in temperature.
Oh,
And
okay.
this is what we call the specific heat. Clear? So if I want to derive the dimension of specific heat, so this would be delta Q by M and delta T. Now, this heat is a form of energy. So you can directly tell me that what would be the dimension of this heat?
It will be equal to energy, right?
Yeah, energy. So this is energy. So this would be
L.
ml squared t minus 2.
Okay.
And this is mass. So this is m. This is O, who is doing. So this is delta T temperature. So this is K. Right. We denote the dimension of temperature because we have already used a T.
We are
Time.
using kinetic energy.
No, no, no. K is not the kinetic energy because K is the derived one. Right,
Okay.
kinetic energy is the derived one. These are the fundamental ones. So temperature, mass, length, these are the fundamental one, right?
Okay.
So yeah, because kinetic energy has this dimension, right? Not
Yeah.
K. Yeah, so this M and this M will cancel. So what will be in dimension? This will be L square T minus 2 K minus 1. So this is the dimension of specific heat.
Okay.
Clear?
Yes.
Yeah, and then you have the surface tension as well, and then
So can you
Young's law.
just tell what does K denote? The temperature, right?
Yeah, so this is, so I guess we have to join some rule, right? So this K represents temperature. So the dimension of temperature.
Is it Kelvin or something, or just
Yeah,
temperature?
K, just K.
Okay.
Because why we are not using T? This should be T, right?
Yeah.
But
No, time. This will become time
yeah,
then.
yeah, but there would be confusion with the time. So that's why the people decided to use K because K is related with Kelvin. So that's why we have this K. Right.
Okay.
Okay, so do we need to join some room?
Uh, Sir, I didn't get any.
Yeah, so I guess let me ask. Yeah, give me one moment. Yeah, so I've asked him. Oh, so Nuha has joined the other group, right? Okay, we will be in this mail. Yeah, so is it clear? This is
Yes.
specific heat part. Now
Yes.
let me, because these second, third, and fourth, these are important ones, right?
Yeah.
So do you remember the derivation of formula for the time period of simple pendulum? Do you remember that?
Oh, you mean that one?
Yeah, that one. Do you remember that? You have forgotten. Okay, so it's all right. It's all right. We will do this when we will do this
Sir,
question. Then
I did not revise it.
yeah,
Uh,
yes, yeah,
okay.
yeah, because you have your exams which are near, right? So when is your exam?
Next Thursday.
Next Thursday. So, and how many chapters are coming? Did you get this
First. Yeah.
first two?
Yeah.
Oh, good. So we have almost completed this next Thursday. Next Thursday, 16th
Yeah.
of May.
Huh?
16th of
Next
May.
Thursday, 16th?
Yeah, so today is 12th May and then 12 plus 4, 16. 16th of May or 23rd of May.
Sir,
When
you
is
mean
that?
like next 22nd, right? Of May?
Oh,
22nd.
22nd. Oh, so you're saying the next, so the upcoming, not the upcoming, but the next.
Yeah.
Yeah, so then 23rd of May, right? 16 and then
22nd of May, right?
22nd, because today is 12th of May, then Monday, Tuesday, Wednesday is 3rd. So Thursday is 16th May. This is Thursday. So
Oh,
next
23rd,
Thursday,
23rd. Oh.
yeah,
Huh.
so okay, so
Oh.
23rd, then we have a good amount of time, right? Then we'll be able to
Sir, either it's on 22nd or it's on 23rd because no, I think it's on Wednesday, sorry, not Thursday. Wednesday.
Thursday.
22nd.
Okay, so 22nd. Yes, yes. So I guess in this week we will complete this chapter. Right? And
Yeah.
if we require some extra classes, so we can arrange that also. And you please revise all those questions, right? So how much,
Yes.
whatever questions we have done. So in the second chapter, what is remaining? This, yeah,
Acceleration.
acceleration part we have done. So only remaining parts are the free fall
Oh.
and circular motion. We have circular motion, so that I will have to check. So free
Sir, I
fall
mean,
is
sir in the class has not yet completed, so I
yeah.
don't
So
know. I think they
okay,
will improve though. They'll finish it off fast, whether the student
yeah,
understands or not.
yeah. So that's why he is rushing, right? So if he starts integration differentiation, then you know that how
No,
much
no,
time
then
it will.
it will take very long
Yes.
time. They won't be able
So
to come.
that's why. So now you know the yeah. So he's okay. So you have noted down this part.
Yeah.
And so that's why your teacher doesn't have any choice, right? So he has to complete all these things before the exam, and that's why. So
Yeah.
Okay, so now let us now please do all these things right. So please
Yes, sir.
all do all these questions, and if you face any problem in one of these, so then please tell me.
So
So
what
this
are the
thing,
young modules?
yeah, surface tension part is remaining, and then these two are remaining, right? So I will write only the formulas for you, and then we
Okay.
derive. So surface tension is force per unit length. So this is force by length. This is surface tension. And then you have this Young's modulus, right? So this Young's modulus is stress by strain. So stress is pressure, and strain is dimensionless. So you just have to think about this pressure, right? So Young's modulus will have the same dimension as pressure. Then the third one is Planck's constant. So how Planck's constant is related? So we know that energy is h nu, right? H is Planck's constant, and then V, this is frequency. So what is the dimension of frequency? Frequency is 1 by T, right? So this has dimension of T minus 1. So now you calculate H, which is energy by nu. So this is the thing that you have to calculate, right?
Yeah.
Okay, so yeah, these are the things that you have to practice. And now let us, how much time do we have? Oh, so we have 15 minutes more, so we can complete these ones as well, right? So yeah, did you note down all these
Sir,
parts?
energy by nu, right?
Yeah, this is frequency, right? Let me write this as frequency. So frequency, that is right. Okay, so have you noted down all these portions?
Yes, sir.
So now let us understand this second question. Yeah, so let's do this second question. Now, if we recall derivation of formula from dimensional analysis. So this is what we have to remember, right? So in that one, we were given some dependable quantities, right?
Yes, sir.
So we have to find length, and this length is dependent on, this is dependent upon velocity of light. This is dependent upon gravity, acceleration due to gravity, and this is dependent upon atmospheric pressure. This is C, this is G, and this is P. Right. So to
Yes, sir.
derive the formula, what did we write? So we assumed that let's say that length is proportional to the power of C, right? Some power of C, and this length. So let me write it as small length, and this is also some power of G. This is also some power of P. And then we wrote the formula for this thing, which was K, and then Cx, Gy, and then Pz. This was the thing
Okay.
that we did for the case of the pendulum, right? Do
Okay.
you recall?
Yes, sir. Yes.
So now the question was because we have to find this formula. So to find this formula, we need to find out the unknown things. And what were the unknown things? So those were
X,
x,
Y, Z.
y. So this is the thing that we have to find, right?
Yes,
And
sir.
we have to use the dimensional formula. So before we use the dimensional formula, write let us write the dimensional formula for all these things. So L has the dimension of L, and we don't bother about these coefficients, numbers. So this we don't care. Then we have this light, velocity of light. So this would be right.
Yes, sir.
And then we have this G. So what would be the dimension of G? What is this dimension?
So for like same as the acceleration, right?
Yeah, so yeah, this is acceleration, right? Acceleration due to gravity. So what would be this? Just remember the units, meter per second square. So meter per
And
second square, right?
okay.
Now we have pressure. So even I don't remember. So pressure is force by area. So force was what? Force was M L T minus 2, and then area was L square. So this is M L minus 1 T minus 2. This was the dimension of pressure, right?
Yes, sir.
Okay, so now we have every dimension, right? We have
Yeah.
every dimension, and now we will plug all these values in this equation. Let's say this is equation 1. So what would be this thing? So this is right using the dimensional formula in equation 1. We have, what do we have? So we have L, which is C, and this is LT minus 1 power X, and then we have G, which is LT minus 2 power Y, and then we have P, which is ML minus 1 T minus 2 power Z. Right,
Yes,
clear?
sir. Yes, sir.
And now we have to, because this is ML, so in the left hand side, we write that this is M0 and this is T0 because we don't have any powers for M and L, M and T, right?
Yes, sir.
So this is M0, and let's say that this is T0 and this is F. And this one is M to the power Z.
Okay.
And then let's say we have to write L part. So let's write L part. What is the power of L? Can you tell me what is the power of L?
Sir, one.
One, not in the left hand side, right hand side.
Zero.
So this is X plus Y
Good power. Okay, sorry. I thought.
and then minus Z. Right.
Yes, sir.
And now what is the power of T? What is the power of T? That is minus X minus 2Y minus 2Z. Clear?
Sir, I didn't understand the
Which part? L part or T part?
L part.
L. So what is this
How do
power? This
you
is
power?
Lx.
Yeah.
This is Ly. And this is L minus Z. So you have the base L.
Okay, okay, understood. Yes, sir.
And
Understood.
then, yeah, so the power adds up, right? So for
Yeah.
the same base, power adds up. So this would be x plus y minus z. Okay.
Yes, sir.
So similarly, we have this t as well, right? So t has minus x, minus 2y, minus 2z. So this is the thing. Okay. So now comparing LHS and RHS, we get. So what is the power of m in the left hand side? That is 0. So z would be 0. Comparing m. Right.
Yes, sir.
And now comparing L. So if we compare L, then what we will find out? If we compare L. So what would be the equation that we will get? What is the left hand side? L. What is the power of L in the left hand side?
X plus Y minus Z.
Left hand. Okay, so this is in the
And
right hand side,
X.
right?
Yeah.
And left hand side we have 1.
Sir, isn't this the opposite?
Yeah, left hand side is 1.
Yeah. So you have to write 1 is equal to X plus Y minus Z,
Both
right?
are same. So I write 3 equal
Yeah,
to,
yeah. Okay. Understood.
because we always write the variable in the left hand side, right? So
Yeah, yeah.
just for the conventional part, we can write 1 equals to x plus y minus z. That is also correct, but just for the convention, right? So this is the second part, and this is comparing L. Now the last part, if we compare T, then what we will get?
Sir, it will be minus X minus 2Y minus Z is equal to 0.
0. Good. So this is comparing. What is
I
it?
remember this now, sir. I somewhat
Oh, so
remember.
now you good.
Yeah. After
Yeah.
after doing this, I somewhat remember.
Yeah. So this is the thing that we are doing. We are just comparing, and then ultimately we'll get the value of x, y, z. That is the goal.
Yes.
Z is
Yes.
0. So this part cancels out,
Yes.
right? And this part also cancels out.
Yes.
So what is the equation that we have? This one is x plus y equals to 1. And this one is minus x minus 2y equal to 0. So we can write x equals to minus 2y. Right.
Yeah.
So x equals to minus 2y. We can put this value in here. So what we will get? This is minus 2y. This is y. And this is 1. So this is minus y equal to 1. So y is minus 1. Right.
Yes.
This one we have, y we have already got. So now we can find out what is x. X is minus 2y. So this is minus 2 and minus 1. So this is 2. So x is 2.
Okay.
Right.
Yes, sir.
So we have got x, we have got y, we have got z. That was the goal.
Yes, sir.
So now we can put all these values in the assumption. So L was, let's assume that K is 1. So this is Cx and Gy and then Pz. So X is 2, G is minus 1, this is 0. So this part goes away, and this would be, L would be C square and G minus is. So this would be the answer. Clear?
Yes, sir.
Okay, so how much time do we have? We have 2 minutes only, so I will have to update this thing. So there would be no assessment, right?
Okay.
There would be no assessment because we just revised all those portions. So I'm getting this link again and again. So I will just write them that no need to. Yeah, we didn't go ahead, right? We just
Yes.
revised these topics. So I will just try that we just did this. Oh, relative motion and graphs. Okay, so that uniform acceleration. I will just try this thing. Uniform acceleration. Okay, so I have updated that. This will be new assessment. Yeah, so how much time? Oh, it's already 9 o'clock. Okay, so we'll stop here and you can try this fourth one.